Good afternoon, student. Welcome back to Mr. Chen's channel. Welcome back to my master class for pre-calculus. So today we're looking at the 8.5 pre-calculus. So 6.4 from the different textbook. This one is the same as section 8.5 from the James Stewart pre-cal textbook. The dot product. Okay, so 8.5. Okay, so for the dot product, the general formula. So let's say we do have two vectors. So vector u, a1, b1, and then vector v, a2, b2. So that vector u times vector dot vector v, we don't say that multiplying or times, dot, okay, so the dot product. So this one is just consider a sub 1 times a sub 2 plus b sub 1 times b sub 2. So once you find out the dot product, the result, it's always a scalar, okay? It's not another vector, okay? So got to be very careful. Not an other vector. So this one is just a scalar. So compute the following dot product where vector u is 2, 3, v, negative 1, 4, w, 0, 3. So dot product u dot v, so 2 times negative 1. Okay, so 2 times negative 1. No need to put in the parentheses, so just basically multiply that a sub 1, a sub 2 correspondingly. So 2 times negative 1 plus 3 times 4. So we got negative 2 plus 12, then that'll be 10. Okay, for that scalar. So vector w dot vector v, so 0, 3 dot vector v. So 0 times negative 1 plus 3 times 4. Okay, like that. So it's negative 1 plus 12, which is 11. And then the rest of that is just similar to what we did, so the vector. And let's do the one that's a little bit complicated. So let's say we do have a scalar. So c, it's a non-zero scalar. So this one, c dot v. So v right here. So negative 1 times c, which is c. And then 4 times c, then that'll be 4c. And then dot vector v itself, negative 1, 4. So this one turns out to be negative 1 times c, negative c, plus 4c times 4, plus 16c. So eventually it's going to be a scalar, so 15c. Okay, so just like that. And this one you want to combine those two vectors first, and then subtract u, and then 2v, and then find out the final scalar. So u plus w, v plus w, so v plus w, negative 1 plus 0, negative 1, 4 plus 3, 7, so v plus w, and then dot, so u minus 2 times vector v, so u, which is 2, 3, minus 2 times v, so negative 2 times 8, negative 2 and 8, excuse me. Okay, I'm putting the bracket. So negative 1, 7, dot, so 2 minus negative 2, then that'll be 4, 3 minus 8, then that'll be negative 5. Dot product, negative 1 times 4, negative 4. 7 times negative 5, negative 35. Combine them, so it's negative 39. Okay, so for C. And then this one you want to find out the magnitude of vector v. So magnitude of vector v, so square root of 1 square plus 4 square. So then that'll be considered root 17. Times the dot product of vector A, vector B. Oh, this one you just want to do it in general. So instead of using those previous number, you want to do it in general form. So which of the following expression are not defined? So you want to find out, the one that's not a scalar. So the first one, well, if you just plug in a number, it's a scalar. Okay, the dot product, this one is the dot product, the result, it's also a scalar. This one, it's also a scalar. But what about this one? Scalar times the magnitudes and not a scalar. And this one right here, scalar plus another vector. So this one, it won't be an expression. This one cannot be defined. Well, because this dot product, the result is always a scalar. The scalar plus the vector, so that doesn't make sense. So this one is not being defined for E. But the rest of those, if you try to plug in a number with the previous given vector, so they're always considered a scalar. Okay, so determine if the vectors are orthogonal, perpendicular. So orthogonal, that means the vectors are perpendicular. So let's say we do have two vectors. One is going this way, and the other one is going this way. So that means they're perpendicular. So that means the angle got to be what? Pi over 2 or 90 degrees. Okay, so the things that what you need to do, you want to find out the angle in between the vectors. So cosine of theta, it's always like u dot v. So all over the magnitude of u times the magnitude of v. Okay, so let's find out. So u dot v, so 1 times 4, so it's 4, plus negative 2 times 2, negative 4. Combine them, so there's no need to find out the magnitude. I mean, you could. So magnitude of u, then that'll be square root of 1 quantity squared plus negative 2 quantity squared, which is root 5. And then the other one here, so 4 squared plus 2 squared. But it doesn't matter, no need to evaluate the denominator. So this one, it's always what? 0. So that equals cosine of theta. So cosine of theta equals 0. There's only one result, 90 degrees, or pi over 2. Yeah, so they're perpendicular, orthogonal. And then the following vector from a square, so let A, so be that vector A is a vector AB, okay? And then B, vector B is AD. Okay, so A dot B, okay, so this one, obviously, if that's perpendicular, so that means it's going to be 0 for the result. That's what we did for the previous one. And then vector A plus vector B. So what's vector A plus vector B? So from initial to the final position, like the one that we did for the previous one. So it's going to be a new vector. So what is that? So it's the vector AC. And then AB plus BC. So AB plus BC plus CD. And then plus DA. Okay, so it's going back to the original position. So what is that? That just gives you the initial point. So point A. Okay, so again, going this way, AB, BC, and then CD, and then DA. Okay, so going back to point A. So find the angle between the vectors. So again, using that formula, cosine of theta. So that goes u dot v all over magnitude of u times magnitude of v. So this one is cosine of theta. Okay, I'll put it up here. So u dot v, so 2 times 1, so 2, plus negative 2 times 1, negative 2. So again, no need to find out the magnitude, because that is always 0 for the numerator. So this one, just leave it. So if the ratio is 0, so that means theta is what? Pi over 2, or 90 degrees. Again, those two vectors, they're orthogonal. And now let's try this one, cosine of theta. So 1 times 3, 3. Negative 5 times negative 2, 10, 13. Well, combine them all together, then that'll be 13. But let's just do one thing at a time. So 3 plus 10. All over the magnitude of vector u, so square root of 1 squared plus negative 5 quantity squared, times square root of 3 squared plus negative 2 quantity squared. So 13 over square root of 26 times, and this one here 9, 4, root 13. Reduce it, root 13. And also this one reduce. So this one is square root of 1/2. Okay, so cosine of theta equals root 1/2, 1 over root 2. So this one is just showing that cosine of theta, 1 over root 2, so which means that the angle is considered pi over 4. Okay, so the angle is pi over 4, or 45 degrees. Okay, so here's another one. So two vectors are equal if and only if their components are equal. Okay, so this one just follow through the definitions. Okay, so the components are equal. So vector u has that point, initial point, final point, or the terminal point. So you want to show that, well, this one you already know that they're equal. So you want to find out the other positions, the end point for the other vector. Okay, so try to work on something like this. And then number 7, so you want to show that the vectors are parallel. If two vectors are parallel, what happens with the angle? Okay, so two vectors are parallel, so that means the angle got to be considered 0 or 180. Okay, so two vectors are parallel. So again, this one you want to do the dot product. Okay, so find out the dot product. So -1 times 1/3, so -1/3. 4 times -4/3, then that would be considered negative 16 over 3 plus -16 over 3. So this one, that turns out to be -17 over 3. Okay, so -17 over 3 for the dot product. Okay, so check that one more time. -1 times 1/3, -1/3. So 4 times -4/3, -16 over 3. Combine them, -17 over 3. And then what you need to do here, so cosine of theta, dot product. So -17 over 3 divided by the magnitude of vector u. So square root of 1 square plus 4 square. So square root of 17 times 1/3 quantity square, 1/9. Okay, so -4/3 quantity square, 16 over 9. So square root of 17 over square root of 17 over 3. Okay, so what do you notice about the ratio? So multiply this straight across. So it's going to be cosine of theta equals -1. So theta, that means what? 180 degree parallel. And then the other one, you want to do the same thing. So using that, the formula, cosine of theta, u dot v over magnitude of u, magnitude of v. So find the value of k such that vector u, it's 2 times 2 comma k, vector v is 1 comma 7 comma k, and our orthogonal. Well, this one is going to be the dot product again. Okay, but this one is a 3 component, so it's like a horizontal, vertical, the depth. Okay, x, y, z, I, j, k component. So try that. And then number 9, vector u is ab. So find the magnitude of u. So square root of a squared plus b squared. So find 2 unit vector of u. So 2 unit vector of u. So then that'll be vector u over the magnitude of u. So it's ab, and then over square root of a squared plus b squared. And then 2 unit vector u. So that means this one we can separate it. A over square root of a squared plus b squared. And then the other one, b over square root of a squared plus b squared. So we can put it this way, or we can just leave it this way, separation. So 2 unit vector. And then find a non-zero vector that is orthogonal to u. Okay, so orthogonal to u, so that means got to be what? Cosine of pi over 2. So that means it's going to be 0. So that means the dot product got to be 0 for this vector. So in order to get that 0, so this one, so a comma b dot question mark equals 0. So in order to get that to 0, so let's say the other one is considered b comma a, okay? Because that a times b minus b times a, then that'll be 0. So the other one would be b comma a. Okay, so find the value of k such that the norm of k times vector v equals 5. So for v, it's negative 3, negative 4. So there's one of the formula that's showing k is a scalar, so we can always take out the value of k. And then find the norm of v first. So we do know that's 5. So the norm of v, which is what? Square root of negative 3 square plus negative 4 quantity square. So k times, well, 9 plus 16, which is what? Root 25. So that equals 5. Okay, so that means k must be what? 1, right? So you try to take out k there. But the thing is that k could be inside or outside. So if that can be inside or outside, so that means this number, it could be either negative or positive. So plus minus 1. Okay. And then finally, so for the projections, so in order to find out the projections, so the projection of this one is the projections of u on v. So this one is just like u dot v all over the magnitude of v. Okay, let's put in this form. So the magnitude of v times the unit vector of v. So basically this one is just like u dot v all over the magnitude of v squared times v. Okay, so this one u dot v. Okay, so let's do the following problem. So find the projection vector w1 of u negative 4 comma 8, okay, onto v negative 8 comma 1, and find that w2. Find the projection w1 first. Okay, let's do that. Okay, so that means u on v projection. So u dot v, we do have negative 4 times negative 8, which is 32. 8 times 1, then that'll be 8. So v squared. Okay, so that one, it's just the norm of v, vector v. So square root of 64, negative 8 quantity square. So 64, 1 square, 1. Times itself. So that means what? 65 times v. So vector v, negative 8, comma 1. So we do have 40 over 65 times, because that one turns out to be a scalar, times vector v, negative 8, 1. So what we found here, it's 40 over 65, reduce, so by 5, so we do have 8 over 13. So negative 64 over 13, comma, a over 13. So this one just shows that it's the vector w, projection of vector w1. So it's negative 64 over 13, comma, a over 13. And what about that w2? So w2, the way to do it, so this one is just vector u minus dot w1. Okay, so vector w2, just u minus vector u minus vector w1. So negative 4 comma 8 minus negative, okay, again, it's a bracket, minus negative 64 over 13, comma, a over 13. So this is something that you guys can finish. Convert that to the same denominator and subtract. Simple algebra. Okay, so that's it. So the way to find out the dot product, again, the dot product, the usage, not only you'll be able to find out the scalar for the two vector, but also you'll find out the angle right between. So it's very important. Projection, we just want to find out the relationship of those vector, the extension of that vector W1, vector W2. So using the projections, so we can find out the other one. Okay, so thank you for watching the video today. So any questions, comments, so please leave that right there on the YouTube comment bar, and then I'm more than happy to reply that. And also, students, you have question in class, so make sure that you ask me about this during class time. So pretty much we're done with the entire chapter 8, so the polar coordinate and the vector. So thank you for watching it once again. See you next time.